And then the final problem for this section is this. We want to find the minimum triangle, circumscribing this ellipse, and we want to find the expression for the height of this triangle. Mm, yeah, so to make the process simpler, I'm going to bring down this ellipse to make this center of ellipse located at the origin. That's the usual coordinate for the ellipse. So, yeah, when there is an ellipse like this, we can make a coordinate plane. And let's make a triangle circumscribing this ellipse. Yep, I like this. And then for the point of tangency, let's connect the origin, center, and the point of tangency. And this angle is theta, and the equation of this ellipse is uh, so this is the standard form of the equation of ellipse. In such case, the coordinate of this point, the x coordinate is a cosine theta, and y coordinate is b sine theta. So we can make an equation of the tangent line at this point. At first, we need to find the slope of the tangent line by finding the derivative. So if we change this equation by multiplying the denominators, and then if we make the derivative of this equation, so we can cancel 2. So, dy over dx. is and then we can change x to a cosine theta and y to b sine theta. Yeah, so this is the slope of the tangent line. And using this point and slope, we can make the equation of the tangent line. So this is the equation of the tangent line, and this point will be the y-intercept of the tangent line. At first, let's multiply this a sine theta to both sides to remove denominator. And we have this cosine squared and sine squared, but because that's always equal to 1, we can make this AB. And then when x is 0, y is b over sine theta. That's the y-intercept. Yep. And for this point means the y coordinate is minus b. So when y is minus b, so we can cancel b. So for this point, this is the x coordinate and y coordinate is minus b. And then now we can find the area of this triangle. For the area, I mean the base times the height divided by 2. So in this triangle, the half of the base is the x coordinate of this point. And the height of this triangle is this b over sine theta plus b. So this is b over sine theta and there is another b. So when you multiply these two, that will make the area of the triangle. That means And using double angle formula, this sine times cosine is the half of sine of 2 theta. And to find the minimum value, we are going to derivatize this expression. So A prime is, we are going to use the quotient rule. Yeah, so this is the derivative, and for the minimum value, the derivative should be 0. And that means this numerator of a derivative should be 0. So if we take just this numerator, they should be equal. So we can cancel these two and this. And then this sine 2 theta is 2 times sine theta cosine theta. And this cosine 2 theta is like, we can change this, the cosine theta to this one, 1 minus 2 sine squared. And then this cosine squared is also converted to 1 minus sine squared. That means we can cancel this 1 plus sine theta. So if we open the parenthesis, sine theta is 1 over 2. So when sine theta is 1 over 2, this b over sine theta, that's 2b. And because this upper one is 2b, and they this also has b, so that's why the altitude of this triangle, the length is 3b, when the area of this triangle is minimum.